Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Stefan Achberger from the podcast team at Omicron, and I will be your host. Hello everyone. This is the second episode of our mini-series called Circuit Breaker Testing Around the World. We want to have expert discussions about what circuit breaker technologies are used, how circuit breakers are tested, and the reasons for these differences all over the world. My name is Stefan, I work at the Omicron headquarters in Klaus, Austria, and I have spent about 6 years focusing on circuit breaker testing all around Europe. In this episode, I have the honor of talking to Bastian Wölke from the northwest of Germany. He has experience in power system testing for many years and is talking to me today from his home office near Düsseldorf. Hello, Bastian, and thank you for taking the time to have this conversation with me today.
Hi, Stefan. Thank you for having me.
Awesome. So before we get into circuit breaker testing, maybe just tell us a little bit about yourself. What kind of background do you have and what is your current job? What do you do?
As you said, my name is Bastian Wölke. I'm working for Westnetz, one of the biggest DSOs in Germany, belonging to the E.ON group. It used to be a part of RWE. And I'm working here for over 25 years now. And I'm specialized in everything that is related to switchgear, especially medium voltage switchgear, circuit breaker testing, diagnostics, partial discharge testing. Yeah, that's my job. I'm also doing trainings for my colleagues because we have a big refurbishment factory for switchgears and a big training center where I also used to work as a trainer. And one of my special parts is also very interesting. It's post-mortem analytics for switchgears that have problems. So I have a lot of experience with things that are not working and to find the root cause for that.
Sounds like you're a good guy to talk to. So you're saying you're working in the northwest of Germany. How big is your area that you actually work in? Are you all over Germany? Are you outside of Germany? What's kind of the area you usually work in?
So the own grid of Westnetz is the complete part of Western Germany. So it's like 300 or 400 kilometers from north to south. And it's typically the area of North Rhine-Westphalia in the west of Germany, close to Düsseldorf, Cologne and stuff like that, going up to the north and to the south. So we have a lot of colleagues that are doing regular maintenance in the area. We have like 16 service stations in this complete grid. And all the colleagues that are working there and do regular maintenance need to be trained, for example, and need to be serviced by me and my colleagues from the engineering team.
Perfect. So let's get into circuit breaker testing, or maybe first about the European grid in general. What do you think makes the requirements in Europe specific? How is it unique compared to other areas of the world, or maybe specific to your region in northwest Germany?
So as in a lot of areas, our grid is separated into separate DSOs and TSOs, for example. And we have a lot of different voltage levels in Germany, starting from 6 kV up to 10, 20, 30, and up to 110 kV. That's normally the distribution grid. And after that, we have 220 kV and 400 kV AC grids at the moment as transmission grids. So there's a lot of switchgears installed in Germany, a lot of grids, as we have areas where we have a lot of industry parts like the Ruhr area. Typically, there is a lot of energy needed. So we have very intense grid with a lot of substations.
You said up to 400 kV AC for now. There's implied that this might change in future. What's the trend looking like? What do you think is going to happen in future to the grid?
So definitely at the moment, there are things going on with DC links, of course, as Germany is close to the Baltic Sea and to the North Sea, where we have big offshore clusters that used to get more and more bigger. And we need distribution lines from the North Sea up to the south, like Munich. And there are a lot of corridors with DC links are in planning. And of course, switching technologies for that will be necessary. And of course, transmission lines. So there are a lot of projects where they will do this with cables, HVDC cables, big things, but also normal overhead power lines. So very much things are going on at the moment because of the change in the grid with normal coal power plants or nuclear power plants that turn down. And we are getting a lot of energy from the north. So there's a lot of things going on and new technologies step into for Germany in the grid.
So you mentioned the need for DC switching, DC switchgear in general. Maybe not necessarily the focus of this podcast, but maybe can you just say a couple of words of what the requirements are there or what the challenges are in that regard, or how you think how those might be tackled once these new DC links are coming up?
Yeah, so first, our colleagues from the transmission grid will need substations for that, especially substations that are installed offshore, so they need to be very compact. Also, the switching or the switchgear technology will be very compact, so there's now DC GIS coming into the part. And mainly we will have a lot of converter stations in Germany where we convert from DC to AC again. That will be very big substations with new technologies. But also, as you said, DC switching is a very special thing. I think there will be a lot of things that need to be developed, especially then for testing, of course.
Yeah.
But luckily, that's up to my colleagues from the transmission grid.
Good to know that the problem lies somewhere else. Do you have any idea what the technology right now looks like, how we're going to be able to switch DC currents, or what's the most likely technology that we're going to use?
So I think at the moment, mostly it's like electronically switched in power electronics. That's mainly the part. And switchgear itself, like a new GIS that was presented a few weeks ago for offshore installations, will only include like the bus bar itself and an earthing switch or disconnector. So the circuit breaker technology will be outside in the power electronic part of the substation.
Interesting. Thanks for that outlook to the future. So let's focus on the current state of circuit breakers in Europe. Usually to my experience, in medium voltage, we have mostly vacuum circuit breakers, in high voltage, mostly SF6. How do you see the history of circuit breakers, or why we have these types of circuit breakers in use currently, or also historically?
Yeah, normally I think we came from, in the high voltage part, from air blast technologies over oil as a switching medium up to SF6 that used to be like 35, 40 years ago when it stepped over to SF6, a well-proven technology. And now, of course, we are in a very, very important step where we have this change from SF6 to SF6 resolution. And that's also where new switching technologies come in for high voltage. I think for medium voltage, we have installed in our grid the first vacuum circuit breaker at the early 80s, like 1980, 1981. And those technologies are still in service. But for HV, for example, now all those things are coming in. We have the first pilots running with HV AIS breakers, and also GIS projects are planned. Yeah, there will be definitely a switch in the next years to new technologies.
And with the new technologies, you mostly mean just SF6 alternatives, right? So just gases that have similar capacities, but just different types of gases. Or are we talking about completely new technologies in general?
I think the step in of vacuum switching into high voltage, that is some kind of a big jump for new technologies now, because also we have to think about new ways of testing. For example, if we have a big vacuum chamber installed in a breaker without SF6, we need to have a look at the gas for insulation, a complete new gas like natural gases. But we also need to think about how can we check if this vacuum switching technology inside of the breaker is okay. For medium voltage, we have good solutions with, let's call it some kind of high-pot testing with an open vacuum chamber. But to bring this into high voltage will be a big step. So you would need very high voltage and for that big equipment. And at the moment, we and also the manufacturers are thinking about what are the right technologies to test that.
Okay, so also same as in America, as I had in the first episode, we talked about vacuum also going into higher voltages. Do you know how the technology is evolving that we're now able to use vacuum technology in higher voltages?
Yeah, I think based on the experience from the last 40 years, the manufacturers developed solutions that work also well with high voltage now. In fact, the bigger solutions, bigger vacuum chambers to work with arc distinguishing and current transport, but also there is a combination to have the right mechanical drive for that. So that was, I think, a big step in development to get that working. But as you can see at the moment, especially when you're talking about SF6-free technologies, there are two ways to see in high voltage. One is the one with natural gases and vacuum, but the other ones also have some kind of self-blasting technology switched completely in the new alternative gas. So there are two ways that are open now, and the manufacturers are going on that.
So it's an interesting time to be in the circuit breaker business where you expect a lot of changes coming up in the next years in talking about the distinguishing medium as well as the technology as such, how we're going to have circuit breakers. Plus the additional challenge of even having DC circuit breakers, which might even be electronical. So very interesting times ahead from your perspective in that case.
Exactly. Also, for things that are going on is this data thing that is going around. So everyone is interested in data, and there is a big interest in that the device itself gets smarter. That's also things we can see.
Yeah.
A lot of users are looking, how can I use my data that already exists, that I already have in my SCADA system, to get an effort for maintenance, for example. We can see first manufacturers that try to install small sensors, innovative solutions in the circuit breakers. Also a good and interesting thing. And we will see how this will work.
Exciting times ahead. So let's start talking about testing of circuit breakers. So in the first episode, I kind of asked it in a way, if you go to a circuit breaker and you only have very limited time, what is like the very basic test requirements, or what kind of tests would you perform for a very basic, very simple condition assessment on a circuit breaker?
So you're talking about an HV or an MV solution?
Maybe both. Let's talk about both real quick.
In our company, of course, the first thing we are looking at is breaker timing. So the timing of the contacts itself, it's a combination of course, the coil and the complete drive and the chamber itself. Motion analysis gets more and more interesting because of high speed and heavy load that is inside of the mechanical drive. That is interesting. And of course, for HV technologies, the dynamic resistance measurements is very interesting because we get into more what a doctor works like. We don't open up the breaker. We simply look from the outside with our electronics devices into the heart of it. And then we think about, do we need to open up a breaker or not? So we call it minimal or non-intrusive methods. And that is working absolutely well to do diagnostics for the breakers.
Very interesting. Personally, I would have considered dynamic contact resistance and maybe especially motion measurements to be more of the high end of the circuit breaker condition assessment. You're kind of considering that already as the basic standard test by now. Is that something that has changed in the last years, or has that always been the case?
That definitely had changed because 25 years ago, simply we didn't have the solutions to do this good analysis on site. So that was a time where we did regular maintenance, and there was a decision to open up a breaker, look inside and look at the contacts and stuff like that, put the SF6 out, put it back in. And that definitely changed to using equipment that can bring us this information and to do not any hard works with opening breakers anymore on site. So we have to rely on that data. And that is why we spend a little bit more on it to get the effort of condition-based maintenance. That's where we are then. So that's a very important step.
So you're basically trying to get a look inside of the breaker without ever opening it, just with the testing methods that are so advanced now that kind of gives you just as much information or almost as much as back in the days where you had to completely disassemble the breaker and look into it.
Exactly. So we normally try, if we have our regular maintenance cycles, they are very long, of course.
Yeah.
For example, from our grid, we have in the medium voltage, we have 15,000 circuit breakers to maintain.
Wow.
And there are minimum of 5,000 or 6,000 HV breakers to maintain. It's a lot of things we need to do. And that's why we thought a long time ago, what are the right measurement techniques to get to the best fitting maintenance cycles? So that is where we stepped into diagnostics. And of course, you need experience for that. And because of the breaker we have, it's a very good way to get this experience. And together with what we have, I think it's a little bit special for us. We have an own refurbishment factory in Wesel where we do very intense refurbishment for circuit breakers. That means we can do everything on repairing from corrosion protection up to contacts, everything that is necessary. We gain a lot of experience. And that's where we started from years ago. We simply took a breaker, did measurements with these new technologies, and then we opened it and do some little changes on it, closed it again, did repeat tests and say, okay, look, this curve has changed, this is that, this is that. So that is how we learned a lot of years. And coming together with these thousands of breakers, I think we have a very good knowledge base now that helps us to do very efficient maintenance. But it's definitely based on diagnostics. So especially for a new breaker, like 80% of it is diagnostics and 20% of it is some kind of maintenance work. Let's call it like that.
So basically diagnostics have become more powerful, but also more important in order to allow a condition-based assessment. Very exciting that this is how you were able to learn, because I imagine if you always see the actual inside of the breaker with the diagnostics part of it, you can just learn incredibly much about how it actually connects together and what kind of error or even failure or whatever happens inside the breaker looks in the results. That's very exciting.
Yeah, and that's also how we train the colleagues in our training center. So we have a big training center where we have nearly every typical breaker that is in the grid in Germany, and every of this model is able to be changed something in. That means we make a training with our technology where we say, okay, at the start, after the installation, let's do a fingerprint recording, what the breaker looks like. And after years or with the regular maintenance, take this graphs again and make a second measurement to see what has changed. And that's what we originally do the training in our training center. So that's how our colleagues learn. First do a fingerprint, then we do as a trainer some changes they don't see, and then they have to do measurements again and say, okay, what has changed now? So we do manipulation on the contacts and stuff like that. They can practically learn that, and that is the effort. That is how it works very well to train. You need experienced trainers for that, of course, and a real behavior of the breaker and a real area to turn it, but that works very well. So our training center is a nice spot to train. I think you heard of it, right?
Yes, I think I've been there once like a few years back, but yes, it's always amazing to have so many options for breakers because you can just try around with different types and on different voltage levels, etc. Yeah. And I also agree that usually this is the best way to learn. If you actually perform the measurements, have some faults. I used to do this in our trainings as well, where I just manipulated some kind of claimed connection or something, and then you can actually do some searching for what could have caused it, what could be the problem. Just a question for fun, who usually wins the battle? Do you put in some errors that they can't find, or do they usually figure out what the problem is?
They are well trained, but we have some hard features to find. So that we're always looking at the group, what it behaves like, and then we have some special faults always in our pocket. Depends on our colleagues that are trained there.
So it's an ongoing battle that we can't yet say who really wins.
Definitely. But Stefan, you and your colleagues always welcome to visit us. So I think it's a great area where we can play around with stuff. And that's also our area where we do, let's call it pilots for adapters, for example, for motion analysis. Yeah. That's a perfect playground to test those stuff. It's also a thing I see in the last years, of course, more and more stuff is now possible due to 3D printing, for example. That's a very good thing where you can do like rapid prototyping. You have an idea where to connect your motion transducer, and then you can do it with a 3D printer and test it. So that's also a good thing that got into last year. So for engineers, good times, I have to say. Very good times at the moment. A lot of things are going on.
Very exciting for sure. Thank you for the invite. I'm sure we'll be back in Basel at some point. But let's get back to the testing methods real quick. So you mentioned what used to be advanced methods like motion and dynamic contact resistance is now kind of the basic procedure. So let's go to the more advanced procedures now. If you have a lot of time and you want to get a complete full picture assessment of a breaker, are there any additional tests you now perform that are even more advanced, or is it with dynamic contact resistance, motion, and all the usual stuff? Is that kind of already encompass everything you do or can do?
There are things that normally used to be, or they should always have been standard, but they come more as you have more features on that part. So there are quite simple things that get more interesting, like motor current analysis, for example. Okay. As these drives get more and more compact and there is more and more plastic parts inside of this mechanical drive because it needs to be cheaper and cheaper, those things can lead into more problems. And that's, for example, in the HV part where it's get more and more interesting to do a motor current analysis to see how the motor, the complete drive behaves. And that is also a very good parameter to compare. So if you see any changes there in the motor curve, this motor curve is very interesting. And that's one bit of a puzzle where we try to get our complete view of a circuit breaker. That's what came into new. Beside that, we have the classic things like coil testing, for example. Minimum tripping, coil current, tripping voltage. That are the things you can work well with. Yeah. Static and dynamic resistance measurement, breaker timing with motion together. And I think then you have for the most typical things to go. Beside that, of course, gas analytics is a thing. In the last years, we got very, very good solutions for mobile gas analytics. So especially for SF6 breakers, you can do a lot of things on site. That's important to do an analysis on site and to make a decision on site. That's not to take like a probe and send it to somebody who will look at it in a computer, to do for the trained experts a decision on site. Can we go back into service with that gear, for example? Yeah. And
so if you have more time, basically you just try to get even more information about the breaker in as many areas as possible. It's not necessarily that you apply any new techniques that haven't been around before, even maybe the gas analysis that is now better or easier possible, but it's just getting more and more information about the breaker in as much complexity as possible. That's kind of what you do if you have more time.
Exactly. And then, of course, we have more and more switchgear itself that is gas insulated at the moment, typically with SF6, but it brings us into the part where we have nearly all devices that are installed in that switchgear are completely capsuled, and you cannot have a look at it because, honestly, to say, one of the most important things is that an expert looks with a visual check onto a device. That is still very important, the view of an expert, and that changed, for example, when it comes to GIS, there's nearly nothing you can see. So you need definitely more diagnostic input to make a decision if everything is running fine in the device. That's where we developed some kind of complete solution. We took a circuit breaker analyzer and brought in some more new measurements like motor current measurements for a disconnector or for an earthing switch. And look at the curve to make a decision if this 3-position switch, for example, works fine. That came into new. And of course, what is interesting when it comes to this kind of switchgear is some kind of live testing. Because in a normal grid, you have a switchgear that has like 30 or 40 panels. And 29 of that panels need to stay in service while you do maintenance on one panel. So you need to have a clever solution to do some kind of live testing while the bus bar is in service. And only the field you are testing on can be switched for testing. And that's where we came into with new testing technologies like testing over the voltage presence indicator system. Take signals out of that and interpret them.
Interesting. So we're just trying to get as many different types of information about the breaker from as many different ways that we can actually access, which is harder in gas insulated, but it's not really any new complete type of technology or tests available. It's just getting as much information as possible. Maybe let's be crazy for a second and think about 15, 20 years ahead. How do you think as a circuit breaker going to be tested in the future? Because we talked before a little bit about data and the assets themselves might be a lot smarter. So is it just going to the breaker, connecting your Bluetooth and it tells you already everything you need to know? Or how do you imagine circuit breaker testing in 20 years?
Yeah, that's definitely a thing I'm always thinking about, how this would go on in the next year. So it's this idea, like in a car, there's a diagnostic computer installed in a car and you have this diagnostic socket where you contact your laptop and say, okay, what happened to you in the last years or last kilometers in the car? Exactly. Yeah. That's like a black box that is running with the system. That's one idea. But I think there are also interesting ideas at the moment, and the start for that is often how can I get information with sense with as less information as possible. And one good idea for that is that I've seen from our colleagues is, do I have to install sensors on every device? For example, for disconnectors in AIS and HV. We talked about that you can see a lot of things from the motor current while the disconnector is running.
Yep.
So one idea could be install a sensor in every motor drive of these disconnectors. But the other idea could be install one sensor in the centralized power supply of all those disconnectors together. And then you get a motor current curve and you only have to correlate that data with which switch has switched. So that is an idea to reduce the sensors and make it as simple as possible, because when I'm looking onto our SCADA system, there are already a lot of data. So they know what switch has switched at which time. They know which current they have switched. And you only need to correlate this data with as less sensors as possible. That's a very interesting idea, I think.
For sure, yes. So as long as they're not switching at the same time, you could use one sensor to basically test potentially anything in the whole switchgear.
Yeah, and then you only have to correlate and say this was disconnector 1, this was disconnector 2. Yeah. And we have a pilot running for that with a system our colleagues have developed on their own. And then you get a curve, of course, and numerical data. And this data is checked and correlated by the system automatically. So that is where you can set values then to say, okay, give me a red light if there's something going on and something changed. You're running out of a standard, for example. It would be simply one sensor, for example, for a complete big substation. That's an interesting idea. So the system analyzes itself permanently, That is one idea. And the other idea is what we can see from the market, that more and more sensors come into the devices itself. And they make a combination of data that is in the SCADA system anyway, like current, they calculate or they count switching operations, but also temperature and moisture, for example, motor current. They are recorded by small sensors in a box. And then, of course, as we are in a digital world now, they are sent to a cloud and analyzed. That's what a new world could look like. It gets interesting that those solutions also are on the market now, or step into the market for smaller and smaller devices. For a low voltage circuit breaker, for example, there are also this kind of smartifications available now. In fact, they cost money, and you need to think about, if you have thousands of breakers, do you want to do that? But those solutions get available. It's very interesting.
Thank you for that little outlook and little excursion into the future. So before we come to an end about circuit breaker testing, maybe just one last question. If somebody is quite new to circuit breaker testing and doesn't have the experience as you do, or not the capabilities to open up their circuit breakers right after testing them or while refurbishing them, what advice do you have for people to get into circuit breaker testing, and how can they get experience and develop their knowledge about circuit breaker testing?
What they can do is start measuring. Because measuring has always the good thing if you know how to do it. That's the first step. Basically, you need to be trained how to connect the system and how to operate the system. But the good thing is the buildup of your knowledge always starts after the first test. So if you do a second test of another breaker, you simply compare it with the results of the first one, and so on and so on. So that's the good thing in our business, that you build up knowledge on your own. As long as you do it, you have to do it. So breaker testing with good, compact and reliable systems, and to be trained on that system, how to use it, is a very good start. And then you can do like a shot in the blue and say, okay, I do a test and see what the result looks like. I do the second, same breaker again. Hey, this looks different. Why is it like that? And then you start to build up your knowledge. So that's always a good idea to do it.
So basically, it's just a learning by doing, and the experience comes from actually doing it.
Yeah, because normally you are not able to damage anything with your testing. If you don't change polarity on some auxiliary parts, your measurement, that's always good, cannot damage anything. So that's some part where I say feel free to play and feel free to test and build up your knowledge.
Cool. Is there anything that we have not yet talked about or not yet mentioned that is on your mind about circuit breaker testing in Europe that you would still like to share?
It's very good to see that those systems get very compact and very robust and well to handle. I have a good experience because our company does a lot of service on offshore wind farms in the North and Baltic Sea. And that's for the systems. We also use the systems from Omicron, like the Cibano. And that's always what I call the heavy testing for that. Because when we are running out with supply vessels through heavy weather and storm, to head off to some wind turbine and to see that his measurement system is somewhere outside of the ship, lying in some kind of case, and it's hammering to the North Sea. It's always very good to see that the devices are very robust and handleable for even harsh conditions like this. So everything that is on the market now is very well planned and proven and practically usable. That's what I like. That is what works very well.
So as we said before, exciting times for engineers.
Definitely.
Cool. So before we end the conversation, I started this habit of asking, because I have the chance to talk to experts around the whole world. I would like to talk about the power grid resilience just real quick, because it is very interesting times as well in that regard. We've been talking, especially in Germany, about energy crisis and maybe even potential blackouts during this winter because we have all of these issues. What's your assessment of the power grid resilience in this winter and moving forward?
So at the moment, I'm thinking most of the things are running well. For us as Westnetz, maybe you have seen that on a worldwide press in the last summer in 21, we had this strong flood in our area where we had some of the rivers got over and we had a lot of damaged grid stations and substations. And that is a good area now as we rebuild it completely new. And our team there tries to look into the future and build a grid of the future because there has been so much damaged that it's not brownfield, it's nearly a greenfield installation now. And you always have in your mind that this flood can come back to this area. So our colleagues there develop very good solutions to make the grid more resilient then with compact stations that are much more resilient to water, flood, and the grid is completely planned new, but it's also planned for future, like e-mobility and stuff like that, monitoring, intelligent grid stations. There's everything running in. Yeah, and for anything else, like the gas crisis and stuff like that, I think it will be very important to intense the work to build our grid more and more resilient and with more and more power, because electrical energy, the consume will rise up, and it's very important. As we talked about, this north to south connections will be very important. Yeah, that's the things I'm looking for. And in Germany, there are a lot of things where you have to wait years and years to get an okay to build a new power line. I hope this will get a little bit more faster, because all the energy companies and the TSOs and DSOs are ready to go, but it should be allowed, and then we can build up the grid of the future. But I think the future will be electrified. So very important.
So you see challenges ahead. You see a lot of input and workload that has to be done to make the grid even more resilient. But at the current state, you kind of have a feeling that it is already quite resilient, and you can kind of weather the storms that are ahead if we keep working on it.
We give our best every day to keep it as resilient as possible, definitely.
Awesome. Do you have for listeners any website that they can find out more about what you do, about your training center as well that we talked about? Can they find more information about you?
Yeah, of course. We have an own company homepage. It's westnetz.de. It's westnetz.de. And of course, LinkedIn, that's what I always like to look at and get very good impulses for our branch, for our company there. There we have a profile, and there myself also try to post new things, as we do a lot of pilots with SF63 technologies. That's where a lot of people are interested in. Yeah, LinkedIn is a good hotspot. And if somebody's interested to visit us in the west of Germany, in Wesel, in our training center, feel free to contact us.
Awesome. Thank you, Bastian, for that amazing conversation. I'm happy with all the information you shared, also outlook for the future. And yeah, thank you. I hope maybe one day we can do it again.
Yeah, thank you very much. Bye.
We hope you enjoyed our conversation, and we want to thank you for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing and offers you the matching solutions for your application. This includes devices for testing circuit breakers, which were the topic of this conversation. For more information, be sure to visit our website at omicronenergy.com, and please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.